In this session, we'll look at a technique to create some customized road striping for use in InfraWorks. We'll start by taking a quick tour. On my screen is an InfraWorks model that represents Central Park, New York. Let's assume that we're working on a road reconstruction project. I'm going to use the bookmark menu to jump to that location. I'll choose 89th Street Improvements. Right here, we can see the area of 89th Street between 2nd and 3rd Avenue. Let's assume that the road reconstruction is going to involve all of 89th Street and the intersections in this area. Now, as I orbit the model around, we can see that the data that we have is basically what we get from Model Builder. I've got the GIS streets, I've got the ortho photography, and I have the extruded building footprints. Now, I already have created the reconstruction model for this in Civil 3D. Let's jump over there for a second. Here we can see the corridor that was created from that project. If I zoom in, we can pan around and take a look. As you can see, I've already created a top surface for this corridor. I'm going to select the surface and we'll come up and choose Object Viewer to view that on screen. Let's tip this up and I'm going to zoom in on the 2nd Street intersection. Here we can see that the corridor is modeling the curb and gutter, we've got the sidewalk, and we've got all the definition of the roadway. Let's close this. After looking at this project, I'm going to jump back over to InfraWorks. I have already imported this model into InfraWorks through the use of a proposal. Let me open the proposal menu and I'll choose 89th Street Improvements. If I zoom in, we can see that when the corridor came in, it was converted into a series of coverage objects that perfectly match the top surface of my corridor. We'll orbit this up. You can also see that I've updated the GIS roads using a InfraWorks style to get this as close to the existing conditions as possible. I've added a few other decorations as well. I've got some cars and some trees, some street lights. I'm going to jump up to the other intersection. And if I orbit this around, you can see that we've got some nice striping up here. We'll orbit this around this way. Now, in many cases, people add striping like this using a coverage area, and there's nothing wrong with that. This is an alternate technique. I'm creating this striping using an FBX file. If I tip this up, you can see that unlike a coverage, the FBX will not try and interfere with the coverages or the surface underneath. So we can see that this is matching the crown of my road perfectly. We'll orbit this around a little more. I'm going to jump back down to the other intersection. And we'll set our view. And then if you're interested, I'm going to jump over to Civil 3D and I'll show you how I created the stripes. In Civil 3D, I'm going to zoom in on my corridor, and I really don't need to see some of this geometry. I'm going to hide it from screen. Let me open the Layers panel, and I'll use the Layer Freeze button, and I'm going to freeze the layer containing the corridor, and I'll freeze the layer containing the spot elevations for right now. I'll press Escape. I will then open the layer control, and I'm going to turn on a layer called Striping. If I zoom in, you can see the geometry that I've created. These are all polylines. They were created using traditional AutoCAD functionality, offset, fillet, commands like that. The first thing I'm going to do is convert these polylines into regions. Regions are considered solids, although they have no volume. They'll reflect light, though. To turn these into regions, I will select one of them. I'll right-click and I'll come down and choose Select Similar. That selects all of them. And then I'm going to launch the region command. I'll press enter, and then it deselected my objects, but you can see as a part of the region command it says select the objects to convert to region. I'm just going to hit P for previous and press enter. That will reselect my previous selection, and then I'll press enter again. And you can see it converted those into 114 regions. Just for a second, let's change our visual style. I'm going to open the in-canvas menu and I'll choose conceptual, and we can see how these objects now reflect light. If I zoom in and pan around, we can see that these are perfect with the exception of my crosswalk area. In this case, I'd like to remove this region shape from this one. Since these are considered solids, I can use the subtract command. I'll type subtract, I'll select the object I want to subtract from, and I'll press enter, and then I will select the object I'd like to subtract, and I'll press enter. And you can see one was removed from the other. This is perfect. Next, we'll further isolate items on screen. I'm going to select one of these regions. I'll right-click and come down and choose Select Similar. I am also going to select this top surface. Then we'll open the Isolate menu and I'll choose Isolate Objects. Once isolated, I'm going to hold down my Shift key and the mouse wheel and we'll orbit this up, and we can see exactly where that striping exists in relation to the surface. The stripes are all at elevation 0. They're 2D geometry. We can also see that now that we've orbited the geometry, the surface is reflecting light because it now shows the triangles. I'm going to convert my Civil 3D surface into a solid. I'll do that by selecting the surface, and then from the Surface Tools menu, I'll open the Extract menu, and I'll use the new Extract Solids from Surface tool. I'm going to be extracting solids from the 89th Street top surface. The solid will have a depth of 0.1. Depth probably isn't the best name. I would prefer that said thickness, because I'm extruding this up 1/10 of a foot. I'm going to insert the solid into the current drawing. Let's put it on a unique layer. I'll do that by clicking this layer button. I'll click it again. I'll choose New, and I'll call this $surface-solid. By adding the $, this surface will be at the top of the list. Let's change the color. I'll make this cyan, just so it looks a little different on screen. I will then click OK, and OK, OK, and then I'll choose Create Solid. After the solid's created, let's zoom in and take a look. I'll press Escape to deselect. And I'm going to flip the visual style back to 2D wireframe for just a second. Since that solid was the last object created, it is visually showing up in front. So let me select this, I'll right click, and I'll go to Display Order, and I'll choose Send to Back. Right here we can see the corridor surface, and then we can see how that solid was extruded up 1/10. At this point I no longer need to see my corridor surface, so let's freeze it. I'll open the Layers panel, I'll choose Layer Freeze, and then I'll click that surface, and I'll press Enter. I will then back up. We'll center this on screen. We'll flip the visual style back to conceptual. The solid I've created from my proposed surface now represents where I'd like my striping to be. Let's extrude all of these shapes up through this surface and create an intersection. I'll launch the Extrude command. Objects to extrude. I'm going to create a window around these, and I'll tap my spacebar to flip that to a window selection. Press Enter when finished, and then I can pull these up and extrude them visually through that surface. I'll click to set the height. After doing the extrusion, I have a series of individual solids. Let's union all of these together. We'll create a single solid representing all of them. I'll do that by typing Union, and then I'll select my objects. Once again, I'm going to use a window selection, tapping my spacebar to get the window, and I'll press Enter. If I select this now, we can see that is considered a single solid. Next, we'll find the intersection between these solids. I'll do that by using the command interfere. This is a classic AutoCAD command used to find clashes between solids. For my first solid, I'll select the one representing the proposed surface, and I'll press Enter. For my second solid, I'll choose my stripes and press Enter. AutoCAD then finds the clashes or interference between those solids. I'm going to use this zoom button. I'll roll the mouse wheel forward and zoom in, and you can see the red geometry that was created identifying the intersection between those solids. This represents my striping model. Let me press Escape, and now that I've identified those clashes, I don't want to delete them, so I'll remove this check and I'll click Close. Let's back up. I no longer need these solids, so I'm going to select each of them and I'll press Delete. And I'm left with a perfect solid model representing the striping for my proposed project. Now, since we're going to move this to InfraWorks, we'll assign a render material to it. Let's pan this over. I'll type RMAT to bring up the render material palette. As you can see, my palette is displaying using these nice preview icons. If yours is not, you can always open this menu and change it from list view to thumbnail view. You can do that for both of these panes. I'd like to select a basic white material, so in the search box I'll just type white and I'll press Enter, and then in the library, for right now I'll choose the plastic family. Here's a material called PVC white. I'm going to click, hold, and drag this up and drop it into the window above. That imports it into the Civil 3D drawing. I will then drag this material over and drop it onto my stripe model. And just to ensure that I didn't miss, I will select the model. I'll come over to the Properties palette and I can see the material right here. Let's close the palette. We'll center this on screen. I can now export this geometry as an FBX such that I can insert it into InfraWorks. To export, we'll open the Application menu and I'll choose Export. We'll open this up. I'll choose FBX. Just for the sake of speed, we'll export this to the desktop and I'll call it Intersection Stripes. The data that I export will be based on a selection. I will select my model and press Enter. I'm going to be exporting the objects and their materials, and I'd like the materials embedded. Let's click OK. One more thing, this drawing is georeferenced. If I go to the Settings tab and right-click on the drawing name, go to Edit Drawing Settings, we can see the coordinate system that this model is using. Since this model is geospatially referenced, it will drop perfectly in place in InfraWorks. Let's close Civil 3D and return to InfraWorks. Let me zoom out a little, and I'm going to bring up Windows Explorer. We'll jump to the desktop, and then I'll drag down and find that FBX file we just made. I'm going to drag this into my model, and I'll release. InfraWorks realizes I'm inserting content, and it wants to know what it is. I'll open the type menu, and I'll choose City Furniture. And then for the coordinate system, I'll open the menu, and I'll choose New York, 983, Long Island foot. Same coordinate system being used in the Civil 3D model. I will then choose Close and Refresh, and the stripes drop perfectly in place. Let me zoom in, we'll orbit this around, and take a look. So the next time you're moving a design from Civil 3D into InfraWorks, consider using FBX as a means of visualizing custom striping. FBXs are easy to create, they're easy to place, and they will perfectly match your proposed surface design.